Hi, Professor. This is the videos demonstrating the Python programming of in Lab 5, which includes four parts: HIC, differential equation, heart rate analysis, and game development. So let me start from sharing my screen. Okay, so the first one is the HIC car airbag modeling. So in this case, the airbag equation with airbag or without airbag equation is given for the differential equation. So the objective in this the objective in this part is to plot out graph showing HIC without airbag, just like this. As we can see, so by giving different time in intervals, like in this case 65, 50, 35, and 20, and then we have a different peak of the HIC as well as the time for the peak point. So let's start from the programming, and so I have the lab 5 include the part 1 integration for HIC, part 2 differential equation for the ER unit and ICU modeling. So for the and then in so I'm going to show the heartbeat in Jupyter, and for the last one, the game is in the folder named follow the number. So this is the Python file. Let's start from the first one. If I pour the part 1 into the spider, so I import all the library, the necessary library in order to run the program successfully. And in my code, I have set up the multiple time intervals to plot HIC. So it's a 20, 35, 50, and 65. And so as the equation is given for acceleration without airbag and with airbag. So I just need to write down the same equation. Sorry, give me a second. Yeah, okay, let's see. So I have it with the airbag for the first equation, and the second equation here is for with the airbag. So just and so the integral equations is to plug out from 0 to 4 without airbag, and to plug out from 0 to 100 with airbag. So I set up the time from in the range from 0 to 160 to plug out the different time intervals to see the differences between amongst HIC with different time intervals. So let me just run the program. Okay, there is. So the largest time interval, for example, 65. So the pink light, stand for the time interval 65 here, because it has the smallest time to get to the peak point, and then we could check it here in the website. We could check it here as a 65, so it has the smallest time. it needs a small time to reach the peak point, and then also for the next one, 50, which is the purple line here. So it is the second one to reach the peak point, and then and so on. So for the 35, which is the green line, for the 20 is a blue line. So the function runs pretty good. And I see you in the second video.